Today, we're talking about what might just be the most ambitious, most nerve-wracking software update in all of human history. We're talking about sending a patch across the entire solar system to a computer that was built back in the 1970s.
So let's just jump right in with the big question. How do you even begin to update a computer that's 15 billion miles away from Earth? Well, a small team of brilliant NASA engineers is figuring that out right now, and the answer starts with some limitations that are just truly mind-bending.
All right, first off, you've got to work with a grand total of 70 kilobytes of memory. To put that in perspective, a single email you send with just text is probably about 2 kilobytes. We're talking about a computer with a memory capacity literally millions of times smaller than the smartphone you're holding right now.
And, as if that wasn't a big enough hurdle, the computer itself is running on technology that is half a century old. This is a completely different universe of computing.
Now, this isn't just some cool, what-if scenario. This is a real-time rescue mission. Voyager 1 is facing some really critical failures that could actually end its incredible historic journey for good. So here's the situation. The probe is sending back just garbled nonsense about where it's pointed, and even more seriously, its main thrusters are getting clogged up with fuel gunk after decades of firing. It's already switched to its backup thrusters. If those fail, that's it. Mission over. And you can't just send a mechanic to clean them, so the only hope is a software update.
Okay, so to really get how they're going to pull this off, we have to kind of dive into the technology itself. This incredibly old yet unbelievably resilient hardware that the team is working with. This is really the heart of the whole challenge. I mean, just think about this for a second. The skills you need to talk to Voyager are so rare that just a few years ago, NASA had to put out job listings looking for engineers who still knew these ancient programming languages. Most programmers today have probably never even seen that.
So at the very core of Voyager's brain is its memory. But it's nothing like the RAM in your computer. It's a physical grid of wires and tiny metal plates that holds data using magnetism. And the absolute genius of this is that even if Voyager lost all power for, say, 100 years, its programming would still be perfectly intact when it powered back on.
This is where it gets really, really cool. On Voyager, data isn't some abstract concept. It's a physical thing. To change a single 1 to a 0, you literally have to send a tiny pulse of electricity to flip the magnetic field where two wires cross. Every single bit of that new code is a tiny magnet physically flipped into a new position from 15 billion miles away.
And when you put Voyager's tech side by side with what we have now, wow, the gap is just staggering. Voyager doesn't even have an operating system. Every command is direct, and its data transfer speed, a blazing 160 bits per second. Not megabits, not kilobits, bits. That's a speed that makes old dial-up modems look like science fiction.
So, this whole operation isn't run by just one computer, but 3 of them, all working together like a little team. You've got the main computer, which is kind of the boss, keeping an eye on everything and telling the other 2 what to do. Then you have the orientation computer, which has one crucial job: keep that antenna pointed at Earth. And finally, there's the data computer, which is in charge of storing all that priceless science and those amazing images.
All right, so we've got this ancient tech, and we know what the problem is. The question is, how in the world do you actually get a software update to make that incredible journey from a keyboard at NASA all the way to the edge of our solar system?
Well, it's this incredibly careful, step-by-step process. The engineers write the code in those old-school languages. Then it gets crunched down into the only thing the spacecraft can possibly understand, a long string of 1s and 0s. Then that signal, that whisper of information, is blasted into space to start its very long, very silent journey. And this is the part that just requires an unbelievable amount of patience. After the team hits send, they have to wait for nearly a full day, 22 hours, just for the signal to get there. And then they have to wait another 22 hours for a message to come all the way back, just to find out if it even worked.
See, Voyager's computers aren't just, sitting there waiting for a call. They are constantly busy running their programs collecting data. So the software update has to be sent with a special signal, an interrupt, that basically taps the main computer on the shoulder and says, hey, stop everything you are doing right now. This is important. You need to listen to this.
And what's really amazing is this kind of high-stakes, long-distance computer surgery. It's not even the first time they've done it. The mission has this long, incredible history of pulling off these seemingly impossible remote fixes.
I mean, if you look back at the mission's history,
It's just one miracle after another. Back in 1989, they rewrote the camera software on the fly so it could take pictures in the super dim light way out at Neptune. In 2010, a cosmic ray flipped a single bit of memory, and they sent a patch to flip it back. And then, in 1995, they sent up a special fail-safe program that would just sit there dormant for years.
And yeah, that fail-safe code, that's a story in itself. They uploaded it in 1995, and then almost 20 years later, a completely unrelated hardware problem popped up, and that dormant code, it kicked in, just like it was supposed to, and saved the entire mission. Can you imagine having the foresight to write a solution to a problem 2 decades before it even happens? Just incredible.
So when you add it all up, all of this work, spanning nearly half a century, it really speaks to the incredible endurance of this mission. It's just a stunning testament to human ingenuity and brilliant engineering. You know, when you really stop and think about it, maybe the most amazing part of this whole thing is just this. The original, physical hardware, the actual wires, the transistors, those little magnetic plates, they are all still working after decades in the unbelievably harsh, cold, radiation-blasted environment of deep space.
And that kind of brings us to a final, bigger question. In our modern world of disposable tech and constant software updates, what can this 50-year-old spacecraft, built on code that was simple, robust, and designed to be repaired, what can it teach us about how we should be building technology that's meant to last? It's definitely something worth thinking about.